What's up, guys? It's your friendly neighborhood Raymond here, and today we're going to be going into another Leetcode problem for the daily. If you don't know who I am, I'm a top 8% elite coder. I've solved over 900 problems, and I'm here to show you how to do this problem. So let's get into it. We have a nice easy statement here. Given an array of nums and integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. This means that, right, so like we've got here, this subarray has 3, right, 3 odd numbers in it, and this subarray has 3 odd numbers in it. Now, that totals to a sum of 2, and so we're going to do that, and then same thing with this one, right, we go through this, we're going to look at that. So this problem is actually like pretty difficult. I would consider this like an intermediate to advanced problem because it's using like a couple tricks, and I think that it's using like math, honestly, like if, for the solution, a little bit of combinatorics. And I think that's what makes it like just a little bit more difficult. But anyways, I just going over like some observations, right? So some things we probably want to think about is, can we use, like, we see subarrays. So we want to think, can we use like sliding window here? Or at least generally, I think that's like an okay, thing to kind of think of, is because these things are connected. And we can't really, because this is a stable like thing, right? Like 3 odd numbers, but like odd numbers can expand out. So this sliding window is not really going to work here because we need to scan the entire array. So that one's down. Another idea you might want to think about is DP. And I'm kind of curious if there is a DP problem. I tried and I thought about it, but I don't know. I think the constraints might be too big. K, where K is 10 to the 5th. So I don't think you can really use DP. You might be able to, though. I don't know. Now, the third idea is some kind of math idea. And this can also come up with subarrays where you have to do some type of combinatorics type of thinking. And in this case, it's going to help a lot knowing that we're going to be using a prefix sum. So let's go to a Scala draw. Okay, so let's go into this first example, right? Let's look at the prefix sum, right? This is actually a really big hint for this problem, is that we want to just separate all the evens and all the odds. So like here, we'll say, now that we have the prefix sum generated, we can try to come up with like some general ideas that we can, do here. This is like a pretty big hint. So I would say, you can pause this video right now if you want to try to think about it, but I'm going to go into it right now. So the TLDR is that what we want to do is notice that like there is like some kind of mathematical property where like this 0 can match up with like all of these, right? So like the 0 here is going to go here. This is a combo. This is obviously good, obviously good, obviously good, obviously good, right? And this same principle is going to apply to these. Obviously good, right? Good, good, good. These are all 2s, right? Perfect. Oh my God, amazing, right? So like this answer ends up being like 4 times 3, right? These 4 multiplied by these, right? That's a really good observation. So we hop here, right? Like we notice this answer is 16 because of the 4 times 3. Now the interesting part about this problem is like, what happens if there's like a 3 here? Well, then all of these are going to combo with that, because these are going to have like the ability to work with those, right? Like if K is 2, so what you're going to notice here is that like once we hit this edge, we can even do the same thing where we're looking for like, some certain number that we can actually hit this match with, right? So in this case, if we're looking for a 3, right, like these pair with 3, and these are going to result in solutions. And so what we can actually do here is there is like some kind of relationship where we're looking for certain numbers, right? This 0 wants a 2. The 0 wants a 2 also, right? And they want all the 2s. They want all of the 2s in order, to generate this answer of 3 times 4, which is 16. The second thing here too is that we also have like this, for this 3, right? This one wants 2 more. So it's going to want this, this, this. These are going to want these. Yeah. And so what you can kind of form is like you could just generate kind of very similar to 2 sum, where we generate like, okay, well, we've got 3 zeros, and let's say we've got 4 2s, right? We just look up when we go to 0, we just look, hey, like, is there a match? And if there is a match, then let's like add that to our final answer, right? Okay, oh, is there a match for this one? No, there isn't. Okay, so we don't do anything, right? And then once we go to this 2, we also want to add in all the 2s like for that match for this one. I believe. So like, you know, this one might have like a 1, but we also want it to match, right? So that's like another case that we want to handle, I think. Although I'm not actually sure. But I do know, like, I am confident about this, right? Where we want to like, have like some general idea that's like this. And honestly, like, I played around with the code and I was really trying to like, you know, kind of get this thing. That said, you know, I think I got it on the first try, at least for accepted, but on March I failed it. But let's go into the code. Okay, so let's go into the code. So we're gonna initialize our prefix sum. We're gonna loop through all the numbers and start like actually filling in our prefix sum. So we've got num mod 2, right? If it's odd, then we're gonna be adding it. If it's odd, then we're gonna be adding it. I have this like initial, you know, statement just because I don't want to go out of bounds. But if it is odd, we want to like increment it by 1. And then if it's not, then we just keep it as the same, right? Just normal standard prefix sum. If you've, you know, again, done your neat code list, done your Leetcode lists. And then we're just going to count everything that's in the prefix using like Python's counter. Go through the answer, or initialize our answer, and then start going through all the counters and then checking, see, hey, does its partner exist, right? Its partner is going to be whatever it is plus k, right? As we saw at the diagram, and then we just multiply it, multiply the combos, and then we have this little case here where we're missing like, you know, one of the combos. So we're going to add that. And we'll run it. And there we go. So this is, yeah, the number of nice subarrays. Again, I think this is like more of a math solution. I don't, you know, understand the math fully, unfortunately, but I do understand like, you know, the basics of the combinatorics of like this idea of we have 3 zeros. And so we want to pair those with 4 of the ones that match, right? To get this 16 number. So that is it. Thanks for watching, and like, subscribe if this was helpful. Okay, and so I looked through like a couple of the solutions, and apparently this problem has like 2 kind of interesting bonus ideas that I hadn't even considered. One is like sliding window, and the other one is like a mathematical trick. If you've taken discrete math, you probably recognize this. Exactly k times is at most k minus 1. So you can do like this recursive solution where you can go through and calculate k and then k minus 1. This is like a mathematical pattern that you'll see. And then for sliding window, which is very, very weird, but you can actually just check and then just, so like go through here and you can expand out until you find a match, and then you start shrinking your window until you find another match. So here you would get 2. And then here, what you do is you expand out until you get the match, and then you add up all of these. So then you add 5 or 4, whatever, add 4, or I guess it's 5 in this case. So 5, 5, 5, you'll get like 15. And eventually you reach the edge of the window, so you don't count it, and then you just keep going, and eventually you're gonna hit, I believe, one other one. I think it might just be this one, which would be 1, because this one is like gonna be the final one. So you don't actually count that, but you count, you know, 5 tier for all of the space that was here. And this code was, you know, is right here, right, where you just go loop through it. You have a left pointer for your sliding window, which is this I. And then you check if it's odd. He's doing like bit masking to check if it's odd as opposed to modulus. And k minus 1 count. And this is if it's odd, you reset the count. And if it's not odd, then you remain the count because it's going to count for everything else that's here. Again, this is, I think, advanced, but worth knowing. I guess this is just a little bonus segment to that other solution that I just wanted to go over really quickly.